we will go ahead. There are like this type of situation is there in India, like overhead cables will be there. Like there are two wires. The first wire is A, wire is B. The current in first wire is IA, current in second wire is IB. Distance between the two wires is D. But now I want to limit myself to a particular length. Okay, from here to here only. Okay, I want to limit myself. I want to find out the force of one wire on another wire. See, when two wires are close to each other, definitely there is a magnetic field around first wire and there is a magnetic field around second wire. Means what? When this is the current around it, there is a magnetic field. The same implies to this also. So when the current is flowing in the first wire, so the second wire falls in the magnetic field of the first wire. Similarly, first wire falls in the magnetic field produced by the second wire. Understood? See, when the current is moving in the first and second one, there is a magnetic field around it. Means what? Here, there is a magnetic field around it, around first wire, like this, in this way. Okay. Similarly, the second wire also has a magnetic field. Second wire is also having a magnetic, that's B. B is also having a magnetic field. So the second wire, that means what? Suppose this is IA, this is IB, this is B, magnetic field of the first wire and the magnetic field of the second wire. Means second wire falls in the magnetic field of the first wire and first wire falls in the magnetic field of the second wire. Due to that, both of them are experiencing forces. Some force is experienced by each wire. He is asking how much is that force. The derivation is about how much is the force experienced by one wire due to the magnetic field of the second wire. So A and B are two wires. IA is the current in the first wire. IB is the current in the second wire. D is the distance between the two wires. L is the length to which I am limiting myself, the force. I want to limit myself to find out the force. That is the length L. Now the magnetic field, what happens? That means what? BA. That means the second wire is under the magnetic influence of the first wire. What is that magnetic influence? BA. And what is this force? FBA. FBA means force on B due to A. Force on B due to A. Suppose if they are carrying the current in the same direction, they repel or they are attract. What exactly happens? That we will discuss. Okay, no need to worry. That I'll explain. Now what is happening? We know the formula. Suppose according to Ampere Circular Law, Ampere Circular Law says that if I is the current, around it there is a magnetic field, and this magnetic field, this magnetic loop is known as Amperian loop. Okay, this is known as Amperian loop. So how much is the magnetic field? According to Ampere Circular Law formula, he says B dot L is equal to what? Mu 0 into I. So what is B? B is equal to mu 0 I by 2 pi r. Why 2 pi r? 2 pi r is the perimeter of the circle. R is the radius of the Amperian loop, and B is the magnetic field, and 2 pi r is the length of the loop, means perimeter of the circle. So this much is the magnetic field. So instead of writing R here, I am writing D. Why? Because I want to truncate, again limit myself to the magnetic field of the first wire and magnetic field of the second wire. So the force, the magnetic field produced by the first wire is mu 0 I into A divided by 2 pi D. Understood? Is that clear, all of you? Is it clear, all of you? Mu 0 I by?
Yes, sir.
Yeah, mu 0 I by.
Yes.
Now, what is FBA? FBA is force on length segmental B due to A. Simple one, force on B due to A. Force on second wire due to the first wire. So how much is the force? According to the formula, the second derivation. When a current carrying conductor is placed in magnetic field. When a current carrying conductor, again I will go back. This is the derivation. This was the derivation. When a current carrying conductor, this is the magnetic field and this is the length. When a current carrying conductor is placed in a magnetic field, what is the formula? Ashas. What is the formula? When a
current carrying conductor placed in magnetic field.
Yeah, what is the formula? F is equal to, what happens in restaurant?
Sir, BIL sin theta.
Ah, very good. BIL. Okay, BIL sin theta. F is equal to F is equal to BIL sin theta. Okay.
Sir, because
So
of
here
you
I'm
only these
writing.
two formulas I remember. Otherwise, one formula also I don't remember.
So don't worry. By the end, before December, you learn all the formulas like in that way. Okay.
Yes, sir.
He's food. He
Yeah.
loves food. So.
Food. He's a foodie guy.
Yes.
Okay. So here we have FBA.
Yeah, Chimpu.
Okay. Force on B due to A is equal to what? BIL sin theta. What is the magnetic field? Force on B due to A. Magnetic field is BAI B into L. Okay, current is moving in the second. This force is what? Force on B due to A is what? How much is the force experienced by B due to A? So magnetic field of A produced by wire A, current in the second wire, and L is the length of the conductor. Similarly, FAB also will become what? FAB will be BB into IA into L. Is that clear? These two equations. Is that clear?
Yes.
So can you explain it again?
Force on B due to A. Force on B due to the first wire. Second wire due to first wire. So that is BIL sin theta. What is the magnetic field? Magnetic field is produced by the A, and current is in the second wire, and L is the length. Okay. Why I am writing like this? The first wire falls in the magnetic field produced by the second wire, and second wire falls in the magnetic field produced by the first wire. Got it?
Yes, sir.
Is that clear? So F is equal to BIL sin theta. Now, so I want to write FBA. What is FBA? FBA is equal to what? So I have already the formula. What is BA now? I'll substitute in this formula. Let this be equation number 1. Let this be equation number 2. So I want to substitute 2 in 1. I want to substitute 2 in 1. So what will be the formula? BA is what? Mu 0 IA by divided by 2 pi D into IB into L. So just multiply it now, simplify this. So this will become mu 0 IA IB into L divided by 2 pi D. So same thing will come. If you want to find out the force on FAB, this also will be same. FAB and FBA will be same, but they will be in opposite direction. FAB will be equal to FBA. Okay. So keep that in the mind. Parallel currents attract and parallel currents attract, and anti-parallel currents repel. Anti-parallel or opposite current. Okay. Anti-parallel currents repel. So what happens? I will tell you. In India, like there are overhead cables. Generally, mostly it will be 3 wires. These 2 are positive wires, and the top one is a negative wire. The top one is a negative wire. These 2 are positive wires, and this is a negative wire. These 2 are kept like with a distance of maybe 1 feet or 1.5 feet, like something like that. So what happens is in rainy season or when there is a heavy wind, what happens is these 2 wires, they get attracted because they are carrying the current in the same direction. They attract. So what will happen? They come and touch each other like this. When there is a heavy wind, they touch each other, and the fuse near the transformer, it will blow off, and the current in that street will go. The current, there won't be any power now. So again, a person from electricity department, he will come and he'll change the fuse, and he'll separate. First of all, before changing he will just see the line. So if these 2 wires are touched with each other, he will just separate them with a stick, and again he will put the fuse and he will switch on again. That's how it is working in India. So what they do is, this electricity department people, they separate these 2 wires with a ceramic cable like this, like a spring material like this, like a ceramic, so that they don't touch each other. Understood? Is that clear?
Yes, sir.
Suppose if it is having frequency, then they will wear a pipe on this one, plastic pipe on these wires. If it is having frequent happening, even after this also, if it is happening frequently, they'll put one pipe on each of them. So that pipe is like a insulating material, so it will protect, okay, from fusing. Clear? Is it clear?
Yes, sir.
So this is very important, and this electricity department people, they have a special, in electricity department, they specially find out how much should be the minimum distance between the 2 wires, so that they don't get attracted. So here we have FBA is what? Force per unit length. How much is the force acting per unit length? That they find out. Means like suppose we have only taken to certain length. Suppose it's like in a street from one pole to another pole, it is around 75 meters. Okay, in India, like the pole distance pole distance for electricity is 100 meters and the pole distance for telecommunication is 75 meters. But now they removed it now. In India, we don't see any telephone poles. Earlier, there were two types of poles, telephone poles and electrical poles. So telephone poles, they removed it now because they have buried all the cables now. But for electricity poles, still they are there. So the distance is 100 meters. So for 100 meters, how much will be the attractive force? That they will find out. Okay, that they do it. So the formula is what? FBA equal to what? Mu 0 into IA IB divided by 2 pi d. This is the formula. Okay, and the force is how much? If one current, 1 ampere current is flowing through each wire and the distance is also 1 meter, in that case they found out that the force is how much? 10 to the power of minus 7 Newton per meter. This much is the force acting on each of them. Is this clear, all of you?
Yes, sir.
Yes.
Do you ask
Yes.
how much is there on IB, the force?
No,
No,
no.
not
Oh,
the
that will be same, no? The force on this and this is same, but only the direction is different, opposite to each other.
But they're asking on this IB how much force is being
Yeah, it's
put.
okay. It's same, no? With the first word to second word is same. It won't change. So now F is equal to this much. So what he will ask, define ampere. How do you define 1 ampere?
So the amount of current flowing through the circuit in one per
I
unit
is,
time.
the formula for current is I is equal to Q by T. Will you write 1 coulomb by 1 second like that? So they define 1 ampere is if the force on each of the wire, is this much, then the current flowing through this wire is 1 ampere. Got it? Don't write this is a 10th, this is grade 10. If you write like this, it is grade 10 definition. So when he says define 1 ampere in this chapter, then you have to say if the force on each of the wire is this much, then the current flowing through the wires is 1 ampere. Is that clear? This particular instrument which is used to find the force on each other is known as current balance. This particular thing is known as current balance, or all this to find out the mechanical force. Okay, the name of the instrument, the used by electricity department people is current balance. And one more thing, like have you seen like when you go from Sharjah to Ras Al Khaimah, there are on the roadside, do you see long towers, electricity towers?
Yes, sir.
Those towers are known as high tension towers. Okay, have you seen those one? And even when you go to Dubai also, from Gises Road, did you notice those Gises Road?
Yes.
When you go to Gises, no, that no, when you go to Gises Road, no, like through Sharjah to Gises,
Yeah.
there are
You pass the airport.
no, not airport.
Not
Just,
airport.
there is a just when you cross Sharjah Dubai border,
Ah. Oh yeah.
long poles are there. You can see
Yeah.
big long poles are there, and they are separated by very long poles are there. Okay, and this is a trespassing.
So towards Medif side.
Yeah, Mirdi side also it is there, and just when you cross Dubai Sharjah, at the border, Dubai Sharjah border, not
Yes,
through
sir.
Salik,
But
through
it's there in the desert also.
yeah, in desert also, Mamzar.
Not to the Mamzar toll gate.
No, not Mamzar toll gate. Normal when you go backside, no, like when you take this road, Al Khan Road, and you go to through the Gises Road, no, where there is no Salik. Remember?
That exact road.
That
Save Salik.
to save Salik. Okay, we generally to save Salik.
Sir, they all are useless people, so they don't know routes.
Huh?
Sir, Aaron doesn't know any routes. He'll simply sleep in car.
What
I'm not here. What is saying?
he's saying, I don't know any routes.
Okay.
I've gone to the
Okay. No. I'm saying like suppose when you okay. Otherwise, did you happen to go to this Ras Al Khaimah,
Yeah, sir.
or when you happen to go to the Abu Dhabi, on the roadside have you seen long big towers?
Yes, sir.
On the roadside you see like high tension towers. Those high tension towers, they carry a current of how much? The voltage is how much? 1,32,000 volts. This much voltage it has. So by mistake, if you go in that area, then final destination, okay, FD. Okay, so the voltage is very high. So what happens is those wires one is having magnetic field. So these two wires will fall into each other's magnetic field. So that is why these two wires are kept as far as possible. So that is why if you see carefully, these two wires are very far, around 1 meter or 2 meters like that, or more than that. That is why trespassing is not allowed. No one is. So there is a fencing around this, across this wiring. There is a fencing down. No one can enter that region. But in India, you have nice, very buildings you can find under the wiring, under this long high tension towers. It's very dangerous, This is very dangerous. If any by mistake, if that cable falls, you cannot expect anyone to leave. It's very high voltage, very high voltage.
And it rains. So
Yeah, when it rains also it is
So,
difficult.
any thundering or lightning happens, does it affect that pole?
Yeah, definitely. Definitely. So that is why here it is safety precautions. They are not allowing anyone to like allowed also. In India, it's not like that. It's something different. Okay. So that is the situation. Okay. So this is about the current balance. So very high voltage is there in those high tension towers. Okay. So you can see that. So that is why there is a like symbol, no, like this. Have you seen this type of danger signal?
FDC.
FD signal. Have you seen this danger signal?
Yes, sir.
And also when it is raining, never touch the poles also in India, like, because the water is there on the wires and the ceramic thing. These wires are here, when they connect it at this point, what they do is, this is the ceramic, there is a water on that one. So current can easily pass through this pole. So that is why never touch the poles, especially when it is rain. In India, here we don't see any poles like that. Okay, it is underground. Even in Chandigarh, I think that in India, Chandigarh is a very planned city, good, well planned city. So in there also, I think there is underground. Did you visit any time, madam?
Yes, sir.
Chandigarh. Have you seen any overhead cables there?
No, sir, not
Yeah,
really.
they say that Chandigarh is a well planned city. It seems. I haven't visited, but
Yes, sir, it's a very modern city. Like all there are buildings and well-maintained buildings, parks, everything.
okay. And also they say that is the only city where in India you won't find overhead cables.
Yes, sir, I've never seen one.
Yeah, this type of poles will not be there. It is underground. Underground, like here also underground.
Sarpanch over there, what?
Water pipe was on
Huh? Water here, all the pipes are like, see, optical fibers is underground, sewerage is also underground, electricity is also underground, and water pipeline, drinking water pipeline is also underground here. But in India, all are overhead. Electrical is also overhead, and also this optical fiber is also overhead. Only water and drainage is this is drainage is open. And drinking is underground sometimes, or sometimes it is overhead also. Okay, this is the problem. Okay, anyways, so here, so that is how we have to work a lot, in India now. So that is why these developed countries are trying to make this is the first important. So when we design any city, how they give the grading, why Dubai got that much importance? Because number one is road system, traffic system. Next comes buildings, infrastructure. Next comes all these four things: drinking water, then sewerage, then electricity, then optical fiber. All these four they see and they give the grading to the city. So Dubai comes in top 10 cities of the world. Not Sharjah, okay, Dubai, okay. And now Abu Dhabi also may go to that level. So now, is it clear? So shall we do a numerical on this now? One second. Situation, my brother's friend, when we were in college, I think, +2 like that. Yeah, overhead cables, yeah. My brother's friend, yeah, actually, his sister's marriage was there, and just I think 1 month before this thing happened, I think there was a heavy rain and there was a wind also on that day, and suddenly the electricity went off. Okay, there was no current in that street. it is very close to this powerhouse region. There was high tension tower, fell down, it broke and fell down. She didn't see that because it was completely dark. She was going to her home. By mistake, she stepped on that wire and she was thrown 50 meters away from, literally she was thrown away. And immediately we took her to the hospital. Then, I think for 2 days, she was like, she was not responding. We thought like we were trying our best. So then the doctor said, no, it's a very, it's like a shock. So it takes time. So after 2 days, she got her consciousness. So that's so, dangerous it is. Fatal. But anyways, by God's grace, she came back again. So that's a, the blood level in her body went to very low. Very low. So that is why live wires are very dangerous. Okay. Yeah, like this. This is a transformer. Yeah,
This is
you can see this one. This is open. This is open transformer. This is ceramic material. Okay, this one. Are you seeing this one? This is ceramic material, and these are the live wires. Okay, actually, this high tension, from the high tension tower, it comes to the transformer. This is the transformer here. Is there transformer here? There will be one transformer here.
Nothing else. That's
Okay.
just the pipe.
Okay. Maybe they have taken this. Okay. So from these wires, again, the wires will go here. This is the high tension. Yeah. Okay, so we'll do a numerical now quickly. There is a question here. Here he says that two long parallel straight wires A and B carrying current 8 ampere, 5 ampere in the same direction are separated by a distance of 4 centimeter. Okay, so here D is here how much? D is 4 centimeter, which is equal to 4 into 10 to the power of minus 2 meters. And the current in the first wire IA is equal to how much? 8 amperes. IB is equal to how much? 5 amperes. And force is equal to 10. Sorry, force we have to find out. And the length is how much? 10 centimeter. 10 into 10 to the power of minus 2 meters. So he's asking force. F is equal to mu 0. We have mu 0 by 4 pi. Yeah, that is mu 0 IA IB L by IA into IB into L divided by 2 pi d. This is the formula. So F is equal to what? F is equal to 4 pi into 10 to the power of minus 7. This mu 0. Current is 8 into 5 into L. What is length? Length is 10 into 10 to the power of minus 2 divided by 2 pi into 10. What is a D is 4 into 10 to the power of minus 2. This will go away. Pi will go away. 2 ones, 2 twos. Okay. So now 4 ones, 4 twos. 2 ones, 2 fours. Okay. So F is equal to how much? 4 5 20. 20 into 10, 200. 200 into 10 to the power of minus 7 newtons. So we'll write in a scientific form. 2 into 10 to the power of minus 5 newton. This much is the force acting on one wire due to the other wire. Clear? Whether it is first wire on second wire or second wire on first wire, it's same. It won't be different. Okay. Only the minus sign and plus sign. Is that clear? Is that clear, all of you?
Yes, sir.
Okay. I am giving you 5 minutes break now. Okay. Take 5 minutes break. Just go around and come back. Okay. Then I will continue. Okay.
Thank you, sir.
Okay,
Sir,
sir.
Yeah. Yes, Shivakshi.
sir, I have to go to Alan, so can I leave?
Yeah. Okay. No problem.
Okay, sir. Thank you.
Okay.